Hi, good afternoon. Welcome to Embedded World 2022. My name is Sri, and today I am going to introduce the LDS bus weather station demo to you. Let's proceed. Here we have an LDS bus weather station that has been set up using Raspberry Pi 3 or 4 3-weeks based framework, and it measures rainfall, wind speed, wind angle, and a few other sensors that we have connected. And the most important fact, this is the LDS bus Python SDK that runs on the Raspberry Pi. It also runs on Microsoft Windows and also any Linux-based platform. Here we have a CO2 sensor and an IAQ sensor, which is also known as the air quality sensor type D from Bridgetek. And we have a curtain motor control that has been set up here to act as a rain curtain. The background shows a greenhouse where the demo tries to measure any rainfall, and it would bring down the rain curtain to prevent moisture from getting into the greenhouse. And then when the rain stops, it will then raise the curtain. Here we have set up a display, the dashboard. This is an open source dashboard that we have used, and thanks to the open source developer. I have the IAQ index shown here. That's very good air quality in this hall. And there is also a VOC sensor. There are no volatile organic compounds measured here. And then we have the indoor temperature, that's 25.3 degrees. And the humidity is quite good, it's at 40 degrees, so the air is a bit dry. All of this data comes from calculations and from various websites. And then here we have the wind vane that shows, right now it is pointing due north, and then there is a speed that's indicated here. It also measures the pressure. This is the atmospheric pressure. We are at a slightly higher elevation here, and that's why you do not see 1,000 for sea level. So this is above sea level. And then down here we have rainfall. So we have been playing around with this demo and shows the cumulative rainfall for today, and that's like showing a lot of rainfall here. And then over on this side here we have the carbon dioxide ppm measurements, and also the light measurement shown in lux. Right, so let's get on with the demo. Here I have an anemometer that is set up to show the wind speed and the wind angle that was pointing due north, and then we have a rain gauge sensor here. So once rain is detected, the curtain will draw down, and then after rain stops, the curtain will be drawn up automatically by the Python program that's running behind. So let me simulate some wind here by pushing this anemometer, and then this anemometer changes are then detected and reported there. I can also change the wind angle to point due east now. So this is east, that was north previously, and you see the values update here. So the wind speed has moved from 10.8 down to 7.2, and then it will go down to 0 as the anemometer slows down. Here you see the wind direction to be at due east, 90 degrees, because I'm pointing now due east. And then moving back to the rain gauge sensor, here we have the rain gauge sensor, and I'm going to pour some water here into this, and this rainfall simulation is then picked up by the Python software, and the rain curtain will then be triggered here, and it moves down to simulate that rain has been detected, and now it tries to protect the greenhouse from the moisture that would then otherwise fill the greenhouse. And then when the rain has stopped, it waits for some seconds, and then it decides that okay, there is no more rain now, and it would raise the curtain again. Okay, so besides that, the CO2 sensor that I have here, you can detect changes in CO2, right? And I can also cover the sensor just to simulate that there is no more light in that area. And then walking over here, we can see that the lux value dropped just now. It went down and then it went back up again. It was momentary. I'm not sure whether the video caught it, but you can see that the CO2 ppm has risen from 500 and it's reporting now 2310 ppm. So all of these values can then be used to take certain actions in your Python program, and the Python SDK makes such a development very straightforward. That's all for the demo. Thank you for your attention. Have a nice day. Bye.